In this video, we're going to review graphing and solving inequalities. So in the front of your notebook and the units of study, make sure you have copied in Unit 13. And then once you get that copied down, turn in your notebook till you run into a blank page. Here's your spine down the middle, and on that side, make sure you write in Unit 13 inequalities and put a little fold in that side, in that corner, so you can get to Unit 13 quickly. All right, so with graphing inequalities, graphing an inequality, you're going to be using these inequality symbols. So an inequality is a math sentence that contains those symbols. So these two symbols are the less than sign and the greater than sign. And then these two, see how they have a little equal line under them? That means they're less than or equal to, or greater than or equal to. So that means the number could be equal to the number, or it could be greater than or less than, depending on what the sign is. So these are the symbols that we will be using for our lesson today. Now, we always read an inequality from where the variable is, because we've been working with variables, and we have to use the variable in our inequality, because we have to figure out what is the variable. So we're going to start with the x's, and I highlighted the x's so that I can see them easily. And we're going to translate what do they say, and we're going to read from x. So in this one, it says x is greater than 2. So I'm going to actually write that out. X is greater than 2, because x is actually greater than 2. Whatever x is has to be bigger than 2. Now for this one, I'm going to read it backwards because x is in the back. So x is on the pointed side of the sign, which means x is less than 2. And then this one, I have x in the front, and it's on the greater than side, but see how there is an equal sign there, or the equal line there? So x is greater than or equal to 5. So what that means is x could be 5 to solve our problem, or x could be greater than. As long as it fits one of those categories, you would be able to get it right. So what I would like for you to do is translate those 3 you try problems, and then unpause your video when you're ready to check your work. And then here are your answers for those 3. So in this one, x is less than 3. But if you look at this one, I have to read it backwards. And it says actually the same thing. X is less than 3. So there's 2 ways you can write an inequality. And then the last one, oops, I made a mistake in that one. My mistake. It's not greater than, because x is on the pointed side of the sign. So this should say x is less than or equal to 6. So x is less than or equal to 6 for that one. My mistake. All right, so let's talk a little bit about how do we graph an inequality. So we have 2 different types of signs. We have signs without equals and signs with equals. Now, when we have signs without equal signs, when we graph, we're just going to draw an open circle on the number. So open circle. However, when we have those equal lines, we actually have to draw a dot, a closed-in circle. So closed circle, and what that tells us is that the point that it is on can actually be included in the solution. So if I look at this one, x has to be greater than or equal to 2. So I drew this like little number line here, and I put 0 on it. So 2 would be here. This spot right here would be 2. 2. Now, if I look at my sign, see how it's equal to 2? That means I have to close in my circle and 2 is included. It's not just a placeholder, it's actually there in part of the solution. And then I have to draw an arrow to say, okay, well, what other numbers could be equal or could be part of the solution? So what's a number that's greater than 2? Maybe 3, maybe 4. So all the numbers that would go this direction on the number line would also be included. So like 3, 4, 5, 6, so on. So the arrow is representing the x. And I want you to make a little note of that. The arrow represents x. So the arrow is what represents x when you are graphing. So if I look at this one, I have x and I have a 3. Well, I know 3 is going to be part of my solution, so here's 0, 1, 2, 3. Here's 3. Now, my question is 3, can x be equal to 3, or is 3 just a placeholder for everything past that? Well, it's not equal to 3, so x is just a placeholder, so we're going to draw an open circle in this case. And then it says x is less than, because remember you have to read it backwards because x is in the back. So x is less than 3. So all these numbers down here that are less than 3, 2, 1, 0, -1, -2, -3, those could all be numbers that you plug in for x that would make this inequality true. So let's practice with graphing a few. So we have x is greater than 0. Well, 0 is just a placeholder because it can't be equal to 0. So we get an open circle on 0, and I have x is greater than 0. Well, all the greater numbers would be this direction. And remember, x is the arrow, and I have like 1, 2, 3, and so on. So that would be your graph. Now for this one, I'm going to put 5 on my line. Here's 5, be up towards the right of 0. Now, because I have this line underneath here, remember when you have a line, that's included, so I have to include 5. 5 can be part of my answer, so I'm going to shade in my circle, but x can also be greater than 5. And where would all the greater numbers for 5 be? Well, they would go up here, because this would be like 6, 7, 8, and so on. All right, looking at this one, I put -3 on this number line, which would be down here to the left of 0. Now, is -3 included in our solution? No, because it's not equal to. So it's just an open circle. It's a placeholder. And it says x is less than -3. Think about, where are the less numbers? Well, if you need that little trick, remember we talked about left is less, closer to the beginning of the year. So this would be your graph for this one, because this would be like -5, -6, and so on. And then we have this one, if we put -4 on the line. I have -4 is included because it has that equal line, so I have to shade in my circle. Now let's talk about what could x be. Well, x can be -4, and it says x is less. Left is less. So left is the less numbers. And if you need to write that left is less, then do that. All right, so I'm going to have you try 2 on your own. So go ahead, copy these 2 into your notebook, and then see if you can graph them. So in looking at this, I'm going to put my 6 on the number line. It would be to the right. And it says x is greater than 6. Now, 6 is not included, so 6 just gets an open circle as a placeholder. And it says x is greater, and greater goes to the right. All these numbers that are greater than 6, 7, 8, 9, 10 could also be solutions. We're drawing an arrow over all of our solutions. Now for this one, x is less than or equal to 3. And 3 is included because it has a line underneath of it. It has an equal line. It can be equal to 3, so I give it a dot. But x can also be less, and left is less. So all these numbers, 1, -1, -2, all those numbers are less than 3 and could get plugged in for x. Okay, so now that we've talked about graphing inequalities, let's talk about solving inequalities. So an inequality can have multiple solutions. Just like we've talked about in the graphing piece, we need to figure out, can certain numbers be solutions to inequalities? So our first example is -7 a solution to f is less than or equal to -5? Well, all you're going to do, instead of putting in an f, you're going to put in -7. So f is going to get replaced with -7, and I'm just going to look at my inequality. Is -7 less than or equal to -5? And if you need to, draw yourself a number line. -5 would be here, -7 would be further down. Well, is -7 left? Remember, left is less. Is that true? Yeah, it is, because -7 would be less than -5. Same thing for this one. Is 3 a solution to -6 is greater than b? Well, instead of b, I'm going to plug in 3. Negative 6 is greater than 3. Is negative 6 bigger than 3? Is a negative bigger than a positive? No, not in this case. So so 3 cannot be a solution to this inequality. All right, so go ahead and copy in this one. Go ahead and try this one on your own. Is 2 a solution to 2 is less than or equal to m? So if I replace m with 2, is 2 less than or equal to 2? Well, 2 is equal to 2. So then yes, that would work as a solution. All right, let's talk about solving more. So it says you can solve an inequality the same way you solve an equation. So all the work that we've done with solving equations actually comes back to review with us for inequalities. It's the same steps. The only thing that's different is that we check an inequality with a graph. So instead of having an equal sign though when we solve this, we're going to draw a line down our inequality symbol. So when we draw a line down the inequality symbol, it's saying whatever is on one side is going to have to happen to the other side, or is equivalent to what's on the other side. So we have to make sure we're balancing it. All right, so when we look at this, here's the x that we need to isolate and get by itself. I need to think about what math I can undo here. So I have x plus 17. I need to undo the plus. The inverse of plus 17 would be minus 17. And remember, we need to do that to both sides. If I do 17 minus 17, I end up with 0. I'm left with x on my first side. Oops, and not an equal sign. Woo! I always make that mistake. In this case, I have the less than sign. So I need to make sure I write in the less than sign. Now I have 15 is 15 minus 17. 15 minus 17 will give me negative 2. So if I read this, and I'm actually going to write it out, it says x is less than negative 2. So x has to be less than negative 2. So if this is 0, and I put negative 2 on here, negative 2 is not included, so I need to do an open circle. And it says x is less. Left is less. So think of a number. What would be to the left of negative 2? Maybe negative 3. Is negative 3 less than negative 2? Yeah. And you could also plug it in here if you wanted to do another check. Is negative 3 plus 17, is that going to be less than 15? It is. So I know that my solution here, x is less than negative 2, is correct. All right. So looking at our next one, I need to solve to get x by itself. So there's my x. I have this minus 3 with x. What's the inverse of minus 3? Plus 3 to both sides. Remember, you work on the side that has the x on it. Negative 3 plus 3 would give me 0, so I'm just left with x over here. Write my inequality symbol. Don't forget it's an inequality symbol. I always make that mistake. And then I have to solve 9 plus 3. 9 plus 3 gives me 12. So I'm going to actually write this out. X is less than, because remember you have to read this one backwards, or equal to 12. And I'm going to graph it. There would be 0. 12 would be up here. It's included because, so I have a closed in circle. It can be equal to 12, which is why it's closed in. And then x is less than x. So it has to go left. So think it crosses over 0. Is 0 less than 12? It is. So I know that my solution here with x is less than or equal to 12 is correct. All right, last two, and I want you to try them on your own. So you have those two problems. Pause your video here, solve those two, and when you're ready, unpause your video and we will check your work together. So looking at number 1, I'm going to draw my line down my inequality symbol. If you need the reminder to write your inequality symbol at the bottom, do that. Sometimes I forget. Here's my g. I need to get by itself. G plus 3. What's the inverse of plus 3? Minus 3. Remember, you have to do it to both sides. Positive 3 minus 3 gives me 0, so I'm just left with G on the back end. 16 minus 3 gives me 13. I'm going to write this out so I make sure I don't make a mistake. It says G is less than 13. Remember, you have to read that one backwards because G's in the back. Here's 0. Here's 13. Is G included in our solution? Is it equal to G? No, it's not. So it's just an open circle. And G is less. So we need to go to the left. And you can check it by looking, okay, 0's there. Is 0 less than 13? It is. So I know that my solution is correct. G is less than 13. And then our last one, we have our x minus 5. The inverse of minus 5 would be plus 5 to both sides. Negative 5 plus 5 gives me 0, so I'm left with x. Don't forget your inequality symbol. And then 9 plus 5 gives me 14. So I'm actually going to write this. X is greater than or equal to. You have half that equal sign. So or equal to 14. So if I graph this then, here's 0. I'm going to put 14 on my graph. 14's included because it says it's equal to 14. So I'm going to close in that circle. 14's included. And it says x is greater. Well, greater would go to the right. Think about what other numbers would be to the right. Maybe like 15, 16. All those numbers are greater than 14. So I know I got it correct. So if you have any questions on your video, please make sure that you let your teacher know. We look forward to seeing you in class, and have a wonderful day.